it's called modern physics. At least when I was in school, this was often offered at various types of programs. And pretty much modern physics, that's what we mean. It's the physics that was that came up and that got worked on and that got contributed by various very amazing, outstanding scientists, primarily in the 20th century. Really, what you end up studying is mostly the 20th century stuff, right? So the early 1900s are very important. The 1905 year, extremely important. Very, 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 very important. Einstein gave us 4 tremendous contributions in that year, including, of course, but not limited to, special theory of relativity. So this, general theory of relativity is not always taught in college physics, in undergrad physics. It is actually a sort of a not compulsory class. It's an elective, a special elective, even in grad school, right? But special theory of relativity is, of course, taught in undergrad. If you take something like modern physics, you will get a flavor of that. So pretty much this whole situation with relativity, which special theory of relativity then goes on to give us general theory of relativity, of course, which gives us the theory for gravitation. That is what we're putting over here. It's the classical physics. And then on the other side, what happened in the 20th century, of course, was developments in quantum mechanics or quantum physics, which is the physics of the very, very small, giving us things like atoms, the physics of atoms, subatomic things, the nucleus, what's within the nucleus. Things are getting discovered even within the nucleus in the 20th century that we knew not of prior to then. We thought the atom might be just it. That might be it. I think atom is a Greek word. Somebody can look up the word atom. I believe it kind of means sort of the smallest foundation of stuff. But please do look this up. Somebody in the chat can look it up right now. The meaning of atom, I do believe it comes from a Greek word. So people literally thought they were ready to, accept the atom as the fundamental block of matter, fundamental little unit of matter. But lo and behold, they found even more smaller things like the proton and then the neutron within the nucleus of an atom. So the atom had more parts to it. And then, lo and behold, even more things were discovered, such as the proton and the neutron are not even the most fundamental building blocks of matter. They even further break down to quarks, lo and behold, And where do quarks come from? They come from particle physics and an understanding, and a superior understanding of particle physics, which is only possible. Why? Because quantum mechanics is extremely successful, even though bizarre, very bizarre. Quantum mechanics is very successful, and it kept pushing, it kept going, and it unfolded into the entire field of particle physics and the families of particles, including, but hopefully limited to, I don't know, because there's just so many particles, leptons, quarks, and bosons. So basically, now we know. So by the way, thank you so much. Stephen did Stephen did a super chat. Thank you so much, Stephen, my friend. Thank you. So this is what was kind of like going down in the 20th century. Very, very productive century indeed. And it has, of course, oozed into the 21st century, especially with particle physics. We continued to get more and more discoveries in particle physics. And some of the questions in classical physics, where there was this push to have a more broader general theory that can not only explain the classical stuff, but can also explain the quantum stuff, because the classical physicists did not like some of the features of quantum mechanics, like uncertainty principle, the probabilistic nature of quantum mechanics, and so on and so forth. But due to the tremendous experimental success of quantum mechanics, like literally the hydrogen atom is a thing, right? And you can look in it and you can see, oh my gosh, yes, there is the proton.